Katriana Popichak, and I'm working in Dr. Chalkin's Parkinson's Disease Research Lab. And what we're looking at is Parkinson's disease specifically. It's a very chronic, progressive, and currently incurable disease. And what we're seeing is death of dopaminergic neurons in the substantia nigra, which is a movement center of the brain. And when we see death of these neurons, we see people basically incapable of controlling very slow and focused movements, and this is pretty bad because it's so very progressive. But what we're trying to do is implicate the role of astrocytes, which is a cell within the brain, and without astrocytes, neurons cannot survive. They supply critical trophic support. And so also what we're seeing in Parkinson's patients is inflammation in these astrocytes, and then also excessive nitric oxide production. And we are trying to implicate the role of NOS2, a gene involved in Parkinson's disease, and nitric oxide production as well. And so we also want to see whether or not, looking at diindolylmethanes, these drugs, we want to see if they're capable of suppressing the neuroinflammation that we're seeing in Parkinson's patients. What I'm looking at is CDIB number 5, and what we are basically showing is that when we treat with an MPTP Parkinsonian model, we see large expression of NOS2, but when we treat in occurrence with DIB number 5, we see a decrease. And this is amazing, this is awesome, because there aren't any drugs out there to inhibit the progression of Parkinson's disease. There are drugs coming out there to treat the symptoms, and so that's what we're trying to do. Also, we wanted to look at the other diindolylmethanes that we have. We have 1 through 14, and we wanted to look at other genes involved in inflammatory expression in Parkinson's disease as well. And being able to do that will allow us to do in vivo studies, and then hopefully we'll be able to use those drugs someday in humans and hopefully help cure Parkinson's.